we're going to be taking you through the steps needed to interpret and conclude a set of data. I'm Freddie, this is Tom, Anna and Amy, and this is fast food. The first job is to acquire the data we intend to study. This can be done by doing a survey to collect the data or by using data already collected from organisations like the National Office of Statistics. Today, the data we're going to be using is from a market research company called Millward Brown and is based on fast food, how often it's eaten and who buying. The data was collected through computer-aided telephone researching. The second step is to ask a question about the data. In this case, the question we're asking is, does your age affect the amount of fast food you eat? So, here we have our data, and more data, and more data, and more data. Recognising a pattern in this data sheet is virtually impossible unless you have a lot of free time.
For this test, we are going to use the categories age and average number of times fast food is eaten per month. The data of both categories will be put into groups. Age groups are as follows: 15 to 17, 18 to 24, 25 to 35, 36 to 54 and 55 to 70. The groups for the amount of fast food eaten per month are less than once, once, twice, 3 to 4 times, 5 to 6 times and more than 7 times a month. Grouping the data helps us refine it into a more usable chunk, which makes it easier to calculate and also shows patterns more clearly. We're now going to visualise all of these numbers, giving us a bigger picture of any trends occurring in the data.
We'll be visualising the data and testing on statistical methods to show you how much easier it is to identify patterns and trends. This graph shows the means for each group. The data is categorical and therefore we cannot use means to explain it, so we have to use medians. The chart demonstrates that using means is inappropriate as it does not show the relevant variations in the data. This graph shows the data in a much clearer way, as medians for each group are used. We can see that the groups of people aged 15 to 17 and 18 to 24 both have a median of eating fast food 3 to 4 times a month. The groups of 25 to 35 and 36 to 54 have a lower median of just twice a week. And finally, the people in these groups aged 55 to 70 have a median of just once a week. But we have to test this data to see if this difference is significant.
As this data is nominal, we need to use a non-parametric test. And since there are more than 2 independent variables, we need to use the Kruskal-Wallis test. The null hypothesis for this test is that there is no difference in the median of the average number of times fast food is eaten between the age groups, and the alternative hypothesis for this test is that there is a difference between at least 2 of them. Here is the equation. Yes, it looks awful. A while ago, this used to be a tiresome process, but fortunately some clever people at IBM have developed a program called SPSS, an analytics program which does most of the work for us. We are, however, going to show you the basis of how Kruskal-Wallis test is done by hand, so that you know what data is used and how it's used. H is the test statistic, N is the total sample size, Ri is the sum of the ranks for the ith groups. Yeah, it sounds silly. You get this by ranking all n values and adding up the ranks for each group. Ni is the number of individuals in the ith group. You then compare the test statistics with the critical value from the chi-square table. Here is the chi-square table. You simply find the degrees of freedom, which is k-1, so in this case 4, and the significance level, which is 0.05. In this case, the value 9.49, so if the test statistics is greater than this, then we reject the null hypothesis.
Now that we've shown you what goes into the original method of calculation, we're going to run it through SPSS. Click on Analyze, Non-Parametric Test, K independent samples, select average per month for the test variable box and age for the grouping variable. Click on Define Groups and enter 1 to 5 in the relevant boxes, since there are 5 categories in this case. Click on Continue and then OK.
The most commonly used value in this table is the p-value, which in this case is less than 0.05. Therefore, we can say we reject the null hypothesis. This confirms that there is a statistically significant difference in the medians between the different age groups. Because the Kruskal-Wallis test shows us that there is a significant difference, but does not define where that difference lies, we have to carry out what's called a post hoc test. This will show us exactly which groups are similar to each other and which differ. Unfortunately, this test does still have to be carried out by hand. From the SPSS output, we can use the mean rank figures to rank the groups in descending order. We then need to calculate the standard error for each pair. We use this equation, where n is the total sample size and ni and nj are the sample sizes for the groups being compared. We then need to divide the difference of the sums of ranks by the standard error figure, which gives you the test statistic. We then compare this with the value from the Q table. If the test statistic is greater, you reject the null hypothesis. After all this has been done, we look at the results. Thanks to the post hoc test, we can see that the groups 15 to 17, 18 to 24, 25 to 35 and 36 to 54 all have an equal median, and that the group 55 to 70 has a different median.
The last stage is to conclude our findings and answer the question we initially asked. So, in conclusion, it appears that people aged 15 to 54 all eat equal amounts of fast food, and the people aged 55 to 70 eat less. So, it appears that your age does have some effect on the amount of fast food you eat.
Thank you very much for watching. Goodbye.